Hello everyone, and welcome back to the last video here in our Unit 2 review for the AP Stats exam. Today we're going to talk about, or in this video, we're going to talk about residuals versus residual plots, how they're helpful, how do we use them, and what types of questions you're going to see on the AP exam regarding residuals. So, it's a fairly short concept and a fairly short video. However, can be incredibly important for your success on the exam. So let's jump right in. Now, residuals themselves. Again, I copied and pasted these definitions directly out of the course and exam description. What I'm going to try and do is break it down and make that plain English for you. This one, though, I don't think is actually that bad. It's the difference between the actual and predicted. So when we actually look at like the formula, if you will, there we go. Our residual equals the actual of y value, which is y, minus y hat. Anytime you see a hat on something like that, it means predicted. That's it. And so sometimes what you might see, very common thing, they'll ask you to calculate the predicted. They'll give you the actual, and then they'll ask you for the residual. That's a very common thing. They may ask you to interpret a residual. So based on this, what I mean by interpret, if your residual is negative, that means the line was an overestimate. Right? If this subtraction is negative, it means the predicted was more than the actual. And so on the reverse of that, if the residual is positive, that means that the line was an underestimate. And so that's another type of question you may see. And so knowing that can help you eliminate answers because you're going to see negative and overestimate, negative and underestimate. And so you'll be able to eliminate at least two answer choices based on those questions if you remember that negative means it's an overestimate, positive means that's an underestimate, without even calculating the residual itself. Right? Obviously, at some point you have to calculate it, and then you can figure out whether it is an overestimate or underestimate. But knowing this as a strategy, I can chop off two answer choices right away. So, residual plots, on the other hand, typically you'll see a couple of things. It's either the residual versus the x values, the residual versus the y values, or the residual versus the predicted values. I've seen all three on the exam. That doesn't actually matter that much. What matters is what you're looking for. What you're looking for is a pattern in the residual plot. If there is a pattern, that means a linear model is not the best choice. If there is no pattern, that means we're okay and we're good to go. Now, when I say a pattern, again, much like other things, this will be blatantly obvious to you. It'll look like a U. It'll look like a V. It'll look like a sine wave. It'll be such an obvious pattern that you will pick it out immediately. It's not going to be something where they ask you to nitpick at this little thing to determine if there's a pattern or not. It will be very, very obvious. Essentially, if there's no pattern, what you're looking for is roughly the same amount of data points above zero and below zero, and no clear cutoff point for where everything is negative and then everything is positive. So, to give an example of that, right, like no pattern would just be something that kind of looks like this. Very simple. Something with a pattern. I'll write this underneath here for you. Something with a pattern would like very clearly look like that. It's going to be so obvious for you. And so residual plots are really helpful in determining whether or not using a linear regression is an appropriate thing. That's what we use them for. So let's take a look here. What do we do if it's not linear? There's a couple of things. You may do some transformations. I haven't seen this in a while on the AP exam. Right, so one of the most common ones is like x versus the natural log of y. That's if we think it's exponential or x versus the square root of y, something like that. In reality, what will most likely happen is they will do the transformation for you, give you a residual plot again, and then ask you whether or not the transformation was appropriate. If it is appropriate and you have to make a prediction, just have to remember to undo the transformation at the end. That's all. So typically, you do not have to do the transformation yourself. They will do the transformation for you, ask you again about its appropriateness, which I'm still looking for the same thing. I'm still going to look at the residual plot they give me and look for a pattern. And then if it is appropriate and they ask me to make a prediction, I just have to remember to undo. So if I took the natural log of the y values, I have to remember now it's e2, whatever that prediction is. If I took the square root of the y values, it's now that value squared. That's all. So remember to undo whatever transformation they did. So let's take a look at an example of what you might see. Now notice this is a residual plot. That's the residual versus the predicted. Fitted and predicted means the same thing. So when I look at that residual plot, there is no obvious pattern to me, right? Pretty much at every x value, or at every fitted value, excuse me, not x value, I have some residuals that are above 0, some residuals that are below 0. There is no clear, obvious U or straight line or anything like that. So is it appropriate? Yes, because the residual plot shows no obvious pattern. And so again, notice my usage of this non-deterministic language. That is very important. The non-deterministic language here is still going to be your best friend. So that is it for our residuals and residual plots. I hope that was helpful, and I'll see you in the next one.